Let's look at the precise definition of limits in this video. We've already learned that if you have the limit, for example, as x tends to a of f of x, let's say is equals to L. In our previous video, we've learned certain techniques, different techniques on how to evaluate limits. Now, in this topic, how sure are we that we are correct? For example, if I have the limit as x tends to 2 of, let me say, x squared, we all know that well, the answer to this will give me 4. How true is this? Then that's when we employ the use of what epsilon delta definition of limits. We will use this concept to prove if the limit truly is equal to 4. Now, what is the definition and how do we prove it? Pay attention to this. The epsilon delta definition, we call it epsilon delta definition of limits, which says that what you are having here holds if and only if and only if, for all epsilon greater than 0, there exists delta greater than 0, such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. Now, this is gist. This is what we call the epsilon delta definition. It states that if this limit of f of x as x tends to a equals to L, the limits hold if and only if for all small value of epsilon greater than 0, there will always exist delta greater than 0, such that, you see, f of x minus L, this is it here, less than epsilon whenever x minus a is less than what? Delta. Now, this statement here means that, you see, the distance between your f of x and L is very, very small. And is small and is even less than a small value, let's say epsilon. Whenever, also, if you look at this part, x minus a less than delta, it shows that x is relatively close to a, but it is not equal to a. Similarly, f of x is close to L, but not equal to what? Not equal to L. So let's see. This is the definition. And take note again, what are you required to do when you are to prove? You have to work towards something. You have to establish the relationship between delta and epsilon. It means that, take note, this delta is a function of epsilon. Take note of that. It means that whenever you are asked to prove in limits, you must establish the relationship between delta and epsilon. If you are able to do that, then this limit is true. Now, let's pick a question. The first question here is, you have to prove if you have the limit as x approaches 5, 4x plus 3. Okay, normally if you solve these limits, you see that you have 4 times 5, 20, plus 3, 20 equals to 23. You have to prove that this is equal to 23. Okay, how do we prove it? Firstly, we define and say solution. For all epsilon greater than 0, there exists delta greater than 0, such that this is your f of x. So you write absolute value of your f of x. So you have f of x plus 3, then minus L. What is your L? Your L is the value for this limit here, which is what? Minus 23. Less than epsilon whenever what you have is x minus a, and this is your x minus a, your a is 5, less than what? Less than delta, and delta must be a function of e. Good. So how do we proceed with the limits? Now this is what we do. So we do like this. So we have 4x. So we have 3 minus 23. That will give me minus 20 less than epsilon. Then this will give me what? If I proceed to factorize, I'll have x minus 5 less than epsilon, and this will give me, this can go out of the absolute value. So I have 4 absolute value of x minus 5 less than epsilon. So therefore, what I'm going to be having here will be absolute value of x minus 5 less than epsilon all over 4. This is what I have. Now, if you observe something, see, absolute value of x minus 5 is less than delta. Here, absolute value of x minus 5 is less than epsilon over 4. Look at this. This shows that delta is equals to what? Epsilon over 4. And this completes the limits. Remember I said something earlier. If you are able to establish that delta is a function of epsilon, that is delta is dependent on epsilon, then you have been able to prove that truly this limit is true. And that is it. The task is that find the relationship between this and this. And that's that for that. Let's take a look at another question. If you are to prove that the limit as x tends to 8 of 1 over 2x minus 3, and what will this one give me? If I solve this, I have 1 over 2 times 8, that will give me 4. 4 minus 3 is 1. Okay. You have to prove that truly this is equal to 1. Alright. We'll start by defining. We'll start by writing the definition that, okay, solution. For all epsilon greater than 0, there exists delta greater than 0 such that you have the absolute value of your f of x minus L. So this is everything you are going to write, but I have it here already. So let me just follow it. So I have half x minus 3, then minus what you have here is 1. So less than epsilon whenever absolute value of x minus a, this is my a here, so x minus 8 is less than delta. So what I'm having here is absolute value of half x minus 4 less than epsilon. Good. So this is what I have. Here. So from here, what do you think I will do? Okay, it's very easy. I can multiply both sides by 2. Let me try to multiply both sides by 2. Do you know why? I'm trying to work towards what I'm having here. You observe that if I multiply both sides by 2 here, it will give me what I have here. Multiply both sides by 2. What we have? If I multiply both sides by 2, I'll be having, this will give me x minus 8, then less than 2 epsilon. So from here, you observe, check what I'm having. You see that I have absolute value of x minus 8, and also I have absolute value of what? X minus 8 here. So it means that I've established that relationship that what? Delta is equal to 2 epsilon. And that completes the proof. Let's consider more problem in this chapter on the precise definition of limits. Okay, assuming you are asked to solve this or to prove, you have to prove that the limits, let's start from the simplest problem, as x tends to 2 of x squared plus 3x plus 7, or let me say negative 7, and this will be equal to, okay, let's solve this. 2 squared will give me 4. 4 plus 6 will give me, this is 4, this will give me 6, that's 10, minus 1, that's 3. Okay, so you have to prove that this is equal to 3. So remember that before we can prove, you have to define that for all epsilon greater than 0, there exists delta greater than 0 such that the absolute value of your f of x, which is x squared plus 3x minus 7, then minus your L, which is this. Okay, let me write the full definition here. Such that f of x minus L is less than epsilon whenever the absolute value of x minus a is less than delta. So let's follow this definition. So my f of x is everything I have here, and that is x squared plus 3x minus 7, and then you have minus L, which is 3, then less than epsilon. So whenever x minus 2 is less than delta. So this will give me x squared plus 3x minus 10 less than epsilon. Now here, if I factorize this, this should give me x plus 5, then x minus 2, then less than epsilon. So if you look at what I'm having here, you actually see that x minus 2 is common to what I have here. And you also observe, I already have this to be less than delta. But the question is, what I'm having here, what is it less than? We don't know. Let me say it's less than question mark. Let us know what x plus 5 is less than. And for us to know what x plus 5 absolute value is less than, we are going to assume. You have to place an assumption that what you have here, absolute value of x minus 2 is less than a small value, let's say 1. Then from here, it means that minus 1 less than x minus 2 less than 1. That's the meaning from here to here. Now remember, I'm going to x plus 5. What will I add to x minus 2 to give me x plus 5? That's actually 7. So if I add 7 to this one, so what I'm going to be having here will be what? 6 less than x plus 5 less than 8. So it means that x plus 5, look at it, 6 less than x plus 5 less than 8. The thing is that choose the biggest number out of this, then write it as absolute value. I'm choosing the biggest number because this thing I'm having here still mean minus 8 less than x plus 5 less than 8. You see, from this interval, minus 8 to 8, 6 is found in that interval. But assuming I've picked something like this, x plus 5 less than 6. By the time I write it like this, minus 6 less than x plus 5 less than 6, I can never find 8 in this interval. You can see 8 is not found in this interval. So if I pick the biggest number, which is 8, then 6 will be found in the interval. Now, after solving this, what will I do? Okay, see what I have here, less than 8. It means that this is less than delta, also this is less than 8. So I can say false. Absolute value of x plus 5 times absolute value of x minus 2. Remember, is less than c. X plus 5 is less than 8. X minus 2 absolute value is less than delta. So both of them are less than what? 8 delta. And remember, they are also less than what? Epsilon here. So I can just say that my 8 delta is equal to what? Epsilon. So my delta is equal to epsilon over 8. Now, so you are not going to put your final answer like this to be equal, that delta will be equal to the minimum. Then you open your bracket, then you have 1, comma, what you have here, epsilon over 8. Then doing this, you have proved that that limit is true as required. All right. So let's look at another problem. Assuming you are asked to prove the limit. Prove this limit as we have x tends to 2 s cubed equal to 8. So prove that this is true. Okay, for all epsilon greater than 0, there exists delta greater than 0 such that the absolute value of f of x minus L is less than epsilon whenever x minus 2 is less than delta. So what will I do from here? Just replace f of x is s cubed. Your L is 8 less than epsilon whenever x minus 2 is less than 8. Now, let's focus on this. Oh, all right. Let's focus on this part. X minus 3, x cubed minus 8. I can write that as s cubed minus 8 can be written as s cubed minus 2 cubed. And recall that if I have s cubed minus a cubed, for example, I'll have x minus a, then x squared plus ax plus a squared. This is what I'm going to get. So if that is the case, I'll write this as I'll be having x minus 2, then s squared plus 2x plus 2 squared, that's 4. Good. Less than epsilon. So I have this, I have this, then I have this 2x plus 4 less than epsilon. Now, see what I'm having here. So what will I do from here like this? You observe that I have this to be what? To be less than. I have this to be less than. I have this to be less than delta. Let me rewrite this here. So I have x minus 2 x squared plus 2x plus 4 to be less than epsilon. Now from here, what will I do? Very simple. Now, so what we are going to do, we already know that this is less than delta from here. But the thing is that we don't actually know what this one is less than. So we are going to find it. Okay, what do we do? Well, let me assume this approach. Let's absolute value of x minus 2 be less than. Remember our former approach, we make it less than what? 1. It means that from here I can say this less than x minus 2 less than 1. Now from here, remember that see what I'm having, and I want to know what this one is less than. What do you think I'm going to do? How can I get this from what I'm having here? Okay, square all the term. If I square all the term, squaring all this term, what will I have? I'll be having this to be 1. If I square this, x plus 2 all square will give me x squared minus 4x, okay, minus 4x plus 4. Then less than 1 square is 1. If you observe what I'm having here, you actually see that I did not get what I need here. So I did not get it. So what will I do? Let's take a look at another approach. Okay, so what I'm having here. I'll still make my assumption. Let x minus 2 be less than 1. So here I have minus 1 less than x minus 2 less than 1. From here, if I add 2 to everything, minus 1 plus 2 less than x plus 2, x minus 2 plus 2 less than 1 plus 2. So this will give me 1 less than x less than 3. So here I have my absolute value of x to be less than 3. Now, what will I do from here? Remember, um, from triangle inequality, see, keep this somewhere, less than 3. Remember that if I have x squared plus 2x plus 4, this that I'm having here is actually less than or equal to absolute value of x square, I can put my square here, plus 2 absolute value of x plus absolute value of 4, which is this. So what I'm having here is less than this. And remember, actually, my absolute value of x is less than, remember, absolute value of x is less than what? 3. So if I put this 3 here, I'll have 3 square is 9, plus 2 times 3 is 6, plus this one is 4, and that will give me 19. It means that what I'm having here is less than 19. I hope you are getting what I'm doing. From here, I got this one. Then I now try to express, just like we have a plus b plus c in absolute value is less than or equal to absolute value of a plus absolute value of b plus absolute value of c. Please take note of that point. So we have this already. Okay. So it means that from here, where I have It means that, remember, x minus 2 absolute value is less than what? Delta. Then this one I have established that what? It is less than what? 19. So I have this to be less than what? 19 delta. So therefore, it means that, remember, this one is less than 19 delta. Also, this is less than epsilon. So therefore, I'll say what? My 19 delta is equal to epsilon. So therefore, my delta is equals to epsilon over 19. So delta will be equal to what? The minimum of 1 comma epsilon over 19. And this gives me the proof. So it means that it is correct. Okay, the last question. What do we do whenever we are having something like this? You have to prove. You have to prove that the limit, okay, let me say as x tends to 2 of 1 all over x is equals to 1 over 2. How do we complete this proof? You can pause the video to give the problem a try. When you are done, you can proceed. So what do? We start by definition. For all epsilon greater than 0, there exists delta greater than 0 such that the absolute value of f of x minus L less than epsilon whenever absolute value of x minus A less than is less than delta. Now, this is all we have. So let's see how we can prove this. Let's follow the definition step by step. F of x is 1 over x, then minus L is 1 over 2, then less than epsilon whenever x minus 2 is less than delta. Now, what do we do from here? When you are faced with something like this, don't panic. Just try to simplify. My LCM here is 2x. This will give me 2. This will give me x. Then less than epsilon. So what I'm having here actually, I can write this as negative x minus 2, then over 2x. But remember that, why am I making it this way? I want it to be, see, I want this to be like, to have resemblance. That's why I'm doing it that way. And remember, this is absolute value. If I have absolute value of minus 3, this will give me plus 3. So this one will vanish. So I'll be having absolute value of x minus 2. Then I can say over absolute value of 2x, then less than 2. Okay? Sorry. All right. Okay. Let me write it here. Absolute value of x minus 2 over absolute value of 2x, then less than 2. Now, when you are faced with this type, we know that we already know. Let me write this way. 2 absolute value of x less than 2. Now, what will I do from here? We already know that this one here is less than delta. But this one, what is it less than? We don't know. How can we find what this is less than? Remember that here, I can't say that this is greater than or greater than something. I don't know. I don't have any clue. With the square root, I could have clue, but this, there is no clue. So what will I do here? This is less than delta, don't forget. And this one, we want to find what it will be what less than. Now remember, you are going to assume that, here, you assume from here that absolute value of x minus 2 is less than a value, and let me pick it to be 1. Okay, now from here, you know that I'll just be saying minus 1 less than x minus 2 less than 1. And what will I do from here? Remember, I want to have x only. So add 2 to all of them. So you'll be having 1 less than x less than 3. Now, this is what you have. Observe. What I want to have here is normally should be 1 over x. And what I'm having here is x. So what will I do from here? Now, take the reciprocal of everything. If I take reciprocal of this one, I have 1. Take reciprocal of x, you have 1 over x. And take reciprocal of 3, you have 1 over 3. Now, Remember that if I have A greater than B in inequality, 1 over A must be less than 1 over B. So if you are taking reciprocal, your greater than will surely go to what? Your less than will surely change to greater than, or vice versa. Okay? Now, what do we do from here? I can write this as 1 over 3 less than 1 over x less than 1. Alright, so I can rewrite it like that. Because if I say A is greater than B, then B is less than A. Okay, so let me erase. Okay, let me manage this. Alright, so this is what I have. So what will I do from here? Okay, remember that when I get stuck at this side, I'll pick the highest value. So I will say the absolute value of 1 over x is less than the highest value between 1 over 3 and 1 is 1. Now, it means that 1 over absolute value of x is less than 1. And remember what I'm having here is 1 over 2. Absolute. It means that if I multiply both sides by 1 over 2, I'll actually get what I'm looking for. So therefore, I'll be having 1 over 2 absolute value of x less than 1 over 2. It means that what I'm having here in disguise is what is less than 1 over 2. Thus, what I have here, x minus 2 times 1 over 2 absolute value of x is less than, now remember this is less than delta. Also, everything I have here, remember everything I have here is also less than what? 1 over 2. So less than 1 over 2, that's delta 1 over 2. That's delta over 2. Good. So I will now conclude and say thus. Remember everything I have here were once less than what? Epsilon. So I will now say therefore delta over 2 equal to what? Epsilon. So therefore delta will be equal to what? 2 epsilon. Therefore, I'm done with the proof. Therefore, I will now say that I will now put my answer the way we should put it, which means that delta will be equal to the minimum in bracket 1, comma 2 epsilon. And this is the end of the video. So that's that for that. So if you are new to this channel, endeavor to subscribe and click the notification bell. Send this video across to students that it will be helpful to. Thanks for watching. Like, comment, share, and subscribe. Thanks for watching.